Okay.
And actually go up. It's been a while since I took DPQ, and I'm definitely going to refresh my understanding of the material once I take it and explain.
Yeah.
But I am definitely looking forward to it.
But this is, I
Yeah, I
mean,
think,
it just gives it all.
teacher assistant, she kind of warned us, just like, well, you're going down that path.
Like they're also like,
You want this? She likes that course, but she don't need it. She's like, it's kind of difficult for her.
That extra day.
That's kind of, every one of the thoughts was kind of like, you know, not even really like excited or kind of whatever about, taking that or going that far, so I'm kind of curious.
Yeah, well, I think mandatory seminar.
I took Calc 1 and 2 in grade school, as part of AP Calculus, and I did very well on the AP exams all the way back then, and I just decided to stick with it because I enjoyed it, and I've
So I'm pretty sure.
computer science, because I took a programming class at primary grade. I actually really liked it. And then, it was all in C++, so I had to teach myself Java once I got here. But the concepts are still the same between C++ and Java. The syntax of code is a little bit different. And I rarely use C++ anymore. I definitely feel that if I were to like go back to this, I would catch up with the C++.
Okay.
It was a bit of a hypothetical. What the hell will be your account?
You take a look at algebra yet?
One of those like rental scooters that are everywhere.
Again, I took that as a page, and it's actually weird because for the CS department here, you need to take a actual class,
See one like
and it's only 2
top
credits,
left
but
screen.
the linear algebra that I took at Berkeley was 3 credits. The traditional way of having linear algebra is they just split up with DPQ into semester 1 course and
You walk there and it turns out it's not right.
So I actually took
on your phone.
linear algebra.
Yeah, like a couple of.
And I had already decided that I want to tack on
Like all the.
linear algebra was, yeah, it's the hardest math class that I have taken so far in my degree, so that I mean it. The professor was
Button says search in this area. You got another button near your like.
That's really good.
result balance. Quiz. What do you expect the refresh button?
Now,
Later, I actually asked the students to try to do the clickers remotely, and it worked. I was standing here. Yeah. You see it. You guys are online if you want to do clickers. It works. Clickers is just amazing. Oh, I'm doing quiz. Know what Malcolm is thinking. He's going to use Teams, and he's going to show this card to the camera on his computer.
That would be
You're
legit.
thinking about that, right?
no, sir.
Because last time your card didn't work, maybe through the camera. Onliners, come on.
I doodled a little bit.
So I should test that. Okay, so this grammar is ambiguous. So if you do, let's say you want to generate AA, for example. You just need to come up with an example, right? So how about you do S, and then you do SS, and then you use this one to do ASA and epsilon, this one epsilon. And then on this one here, you make this one go to epsilon, and then this one you do ASA epsilon. So two different parse trees. Okay? We just need to come up with one example. It's the grammar context free.
Yeah, it works now. Let's go.
Is it working?
Yeah. Colored over it. Now
You
it's not
finish
there.
the coloring?
Yeah.
Looks like I'm gonna have to do that here in a second. It worked. 2 seconds.
Okay, one way, come on.
Oh, there's a liner. Look at that, Richard. Great. The reminders were all happy today because they got 100%. They got to see the carnival. It's not working. It is context free, right? There's no. Okay, this is BNF, so you see program. This is just one variable. Okay. So you have one variable on the left side. Context free. It's not regular, right? Because we have tokens mixed with variables, right? On both sides. So it's not regular, but it is context free because on the left side you only see a single variable. Okay. How many tokens? So tokens are those lexical units with syntax meaning. So if you were to write a lexical analyzer, how many tokens will you define based on that grammar? Richard, I was discussing away, you're seeing away a little bit. Move away a little bit. Camera.
Are you getting the ones up there too?
Oh, Mohammed, I got Mohammed. This one, I don't know. I think it needs to see the whole contour of the symbol. There you go.
Wow.
Sorry.
It worked for the first one. I don't know.
Go online.
All right.
Color it.
Said like a permanent.
Okay, so tokens. Program, so this is a terminal. You want to have this as a token. So that's number one. And then you have ID. ID is a variable. The question is, are you going to create a token for each letter? Do you think each letter has a syntax meaning in a programming language? No, you want to give a meaning, right? A token, assign a token to an identifier, right? Because otherwise it's going to be an explosion of tokens, right? And just a single letter doesn't have a special meaning. Letters together, right, creating an identifier, that has a syntax meaning, right? That's what you want to check. If you have, for example, a statement that has it's an assignment, for example. You need an identifier, you need to check if on the left-hand side of the assignment, there is an identifier. You don't want to check if there are a bunch of letters and then an assignment symbol, which is another token, right? You want to see that on the left side of the assignment, you have an identifier, something that the language recognizes as an identifier. Okay, so you don't want to go that level, going down to the terminal and letter. You're not going to assign a token to each letter. Okay, so all the identifiers you recognize, they will have a different lexical value. It's going to be different names, right? But they will all have the same token assigned, which is the identifier token. So you have 1, 2. This one here, opening braces, it's a terminal, and you want to give this a special meaning because you want to check if I'm creating this block, right? So this has a special meaning. 3 so far. This one here is not part of the language. This is EBNF, right? So this is to show that a statement in a semicolon can happen 0 or more times, right? So these two are special symbols for the EBNF. And then we have a statement. Are you going to create a token for a statement? Or, because it may be different statements, right? So let's look what is a statement. A statement is a print and identifier, right? So you don't want to create a token for a statement, because if you do that, how can the syntax analyzer check this specific type of statement, right? Which is written with a print and identifier. So the lexical analyzer has to go down to the level this time because it needs to inform the syntax analyzer that there is a print keyword and then the identifier following. And then the syntax analyzer will recognize these two together as a statement. But it's going to be, you're not going to assign. That's something that the syntax analyzer will check, right? Because the lexical analyzer is only interested in recognizing parts of your program that has some syntax meaning. But the meaning will be checked by the syntax analyzer, okay? The syntax analyzer understands the grammar. The lexical analyzer understands lexical units with syntax meaning. So I would say 1, right? 2, 3, and then 4, right? Idea I already got, 4, and then 5 for the semicolon, right? And 6 for the closing braces. All right? 6 tokens. aligners. Oh, this is perfect. This is not out. What's going on? I don't know what's going on. It looks perfect. Far away, far away. Move it far from the camera. Move towards you. I'm sorry. A little bit off. I'm sorry. This one didn't work. Oh, we got it, Mohammed. Okay. Oh, good. Okay. It will work, but it will be up to the syntax analyzer to verify the correct order of the tokens. Okay. Some of you said it will throw an exception. No, right? Because the lexicon analyzer will only throw an exception when it cannot recognize a symbol. Okay. And you can say, but I don't know what's the grammar. You didn't show me, right? But just common sense, that looks like an if parentheses a equals to 5 closing parentheses, right? So using common sense, it seems that all these symbols should be recognized, right? So no problem throwing an exception. It will run, but it will notify the syntax analyzer that there is something wrong with the order of the. No, the lexicon analyzer don't care about that. Okay, it's just going to say, it's just going to give the tokens that are recognized in the values. It will run, but it will rearrange the tokens in the correct order. Well, that would be the worst possibility, right? Because the program is synthetically wrong, but the lexicon analyzer is so smart that it's changing, right? The way you wrote the code. No, this doesn't work. Okay? You express that some part of the production is optional.
If those are hints or not. Right.
Nice, Mohammed, it worked. I think it worked, Mohammed. Big bracket, okay? Okay, so last time we were talking about this example of sensitive grammar. I looked before coming to class and I couldn't figure it out, like whether there is a particular reason or not. I think if you can go, this is, I got this example. You see that this is like a screenshot, and I got it from the textbook. I was trying to find from which source I used, but you can see that CB could go straight to BC, right? And I can see that working. If you just make it go straight, like for example, I don't know if you guys spent some time trying to play with this grammar, but I couldn't figure out a particular reason why we have that. So maybe there is. But let's say we have A, and then B. We had BC, right? BC and BC, right? Yeah. I think it was like that. So we can just turn the CBs, right? CB, so I'm going to turn the CB. Instead of doing all that, can I go CB straight to BC, right? That was the question. So I'm going to turn CB into BC, right? And then I'll have CBC. Okay, so, okay. What is tricky is because you should only have one way to generate the production. You can't have a situation where you end up getting stuck in and you can't move forward anymore, right? So maybe the order that you do the changes is important because, for example, another possibility here would be instead of making this one, I will make this one first. Would that create a problem, right? So BCC, right? We have this situation here. Great, so
It's still okay. Turn the CB to BC, and then you guys do it again.
let's do the two tests, right? So now we still have this CB here, right? So we can do A, B, B, and we're going to do BC, right? That's one possibility, and I guess it's the only one, right? Because we only have CB here. Now CB appeared here. This one here, I have CB, and I have only one possibility, right? BC, BC. Okay, now we only have one possibility here, right? CB, so yes. Okay, I'm starting to see the problem because, okay, then we're gonna have BB, right, and then BCCC, right? And then what do you want to do? You want to turn big B's into little b, right? You kind of cannot do that because what if I use that production in the beginning, right? I will end up with a situation where I can't move forward, right? You understand the problem of having, after that, just having B turning to B, right? So I can do that here, but what if I do here? And I get stuck, right? Because I'll have little b and c, so I'll have to create a little b, big C switch, right? So how are we going to turn the b's into c's, right? So that maybe it's part of the reason why we had all these, but can we make it simpler, right? It seems so verbose and complicated, right, to get it done, but I still want to play more with it. I didn't spend too much time, but this is a interesting thing for you guys to also think about it. Yeah.
I feel like that's like baked into the definition of being context sensitive, though. That like there is a way to remove the context in such a way that you couldn't do it.
Yeah, but I mean, you want to create a grammar that would produce the same thing, like the same number of A's coming, the same number of B's, same number of C's, without being a context-sensitive grammar. Is that possible, right? So I will argue that it's not possible, because why would they have that in the example about context-sensitive grammars? But that's not a good answer, right? I'll need to research more to kind of prove to you guys that that language cannot be generated by a grammar that is context-free, right? But I need to research more about it. It's an interesting problem, okay? So just wanted to let you guys know that I'm still looking at that. I don't have the answer yet, but I think you guys should also try to study that and see if you can come up with an answer. Okay? All right. Good. Last time we discussed BNF, and today we're going to talk about the lexicon analyzer in more details. Okay, so remember the compilation process. We're going to begin the lexicon analyzer, is the first phase of this process. Source program is going to be parsed, or scanned. Sometimes they like to call the lexicon analyzer the scanner, and the syntax analyzer the parser. So the lexicon analyzer will scan the source code, will extract the characters, right? Read the characters, and we'll try to come up. We'll try to group the characters in order to identify groups of characters with some syntax meaning, and we'll apply code to those group of characters. That code is the token value. So it will categorize those group of characters based on their token value. Because the token value is going to be important for the syntax analyzer. The syntax analyzer will use those codes to verify if the code is written syntactically correct. So the lexicon analyzer will read the characters of the source code and identify lexical units, also called lexemes. Those are logical group of characters that have some syntax relevance, some syntax meaning. It's also responsible for adding new identifiers found to the symbol table, right? So this, all the identifiers found by the lexicon analyzer will be added into this data structure called the symbol table, right? The symbol table will have information about things that are being identified, names, right, that are being identified in your program. Name of a class, the name of a variable, right, the name of a function. Those are all typical identifiers. The name of the method, the name of an instance variable. Common types of lexical units. So keywords, reserved words. So a small distinction between keywords and reserved words, but at this point, let's treat them similarly. Identifiers, right? So keywords, reserved words, I'm talking about if, while, right? Print. What else? Class, right? Java, class, extends, implements, right? So those are all reserved words. Identifiers, things you're naming in your code. name of a class, right? The name of a interface, the name of an instance variable, static variable, class variable, name of a function, name of a method. All those things are identifiers, variables. Literals. What are literals? Things that, values that you have are coded, right? Like a number. You're assigning 52 to variable A in your code. So 52 is a literal integer. So you like to distinguish between the type of literals. So you have a string, right? A string like hello, string hello in your code. That string is a string literal. Punctuators. So it's common to have in your code punctuations like commas, separating a list of values, right? Columns. When you separate sometimes the key and the value in a dictionary, right? In a mapping structure, you use semicolons. Sometimes you need to end a statement with a semicolon. Period. Period we use, for example, when you call a method from an object, right? Reference variable, you put a dot. So those all have syntax meaning, so they will have a specific token value. Delimiters, that will be parentheses, brackets, braces, quotes. All these things, they also have, usually they're used, of course, parentheses and brackets, they have special use. Most of the times they're used to separate the name of a function or a method call to definition to the parameters. For brackets, usually used for indexing a collection. Then you have braces, normally used for scope, creating a block, and so on. Right? So those are the most common types of lexicon units you will find. Here's an example, right? So you have a typical assignment. So on the left-hand side, you have an identifier, and then you have another symbol for the assignment. And then on the right-hand side, you have an expression. This expression is an arithmetic expression composed of identifiers. You have operators, you have literal values. So here are the identifiers. Result, both sum, and value are identifiers. And then you have the operators. You have the assignment operator. You have two arithmetical operators. And then you have a literal. And don't forget the semicolon. Okay? So before we start looking at implementation, let's do an activity. Make sure you know how to identify lexical units. So let's go to, you still need to do activity 3, right? But I wanted to do activity 4 now. So your goal is, you have these tokens, categories, right? In your description. And I want you to, some of them is already answered. Are they all answered? No. No. Okay, so I want you to put in parentheses the token value. For example, public, use number 1, which is a class modifier. It should be obvious which one to use. Class 2 is a class keyword. Then you have employee. So employee is an identifier. And then you have open curly 9. So 9 is opening curly brace. Okay? And private, I don't know why private is. Okay, private is 4. It's a field modifier. So why don't you continue and put the token values for whatever you're identifying, okay? Try to figure out the best option for each one. don't have to do all of it because this is, the goal of this exercise is just so you begin to get yourself familiarized with the process of identifying tokens, right? But typically, int, right? You can see that number 5 is integer type, so that fits well. And, how about string? Well, ID, we know it's an identifier, right? And then you have semicolon, which is 14, right? I think we need to create one, right, for string. We use employee, we assign 3 as the identifier. But that's the name of the class that we're defining, right? So think about the syntax analyzer, this grammar, that we will have something like private keyword, right? And then type, right? And an identifier and semicolon, right? Of course, the instance variable modifier is optional. It assumes package if you don't specify Java, right? So, but we need a type, right? And the type can be a primitive type or a reference type, right? So I would say reference type, right? The syntax analyzer, it's important to know that that is a type, right? It's not any variable, it's a type. So, but how you specify reference types? Well, that reference type needs to be defined somewhere, right? But it's not up to the lexicon analyzer to figure that out. And then also not up to the syntax analyzer. This is something that it will be resolved later because it's a semantic error, right? Because if you're trying to define a variable, but the type is nowhere defined, right? So something that I'm trying to see if it's the semantic analyzer or maybe even later, because this is a linking problem, right? The definition of string needs to be imported, although we know that string is automatically imported from java.lang. But at some point, the definition for string needs to be available, right?
I feel that isn't a string a container? And wouldn't that just be a class? Because it's technically like an index. And wouldn't that be a 2? Or am I getting it all mixed up?
No, 2 will be class keyword, so it's this class that actually class, right? What I'm struggling a little bit here is whether we would define, because we define employee here in this as an identifier, but here I think we need something else like class type, right? Let's put class type. something that, because you can only have primitive types like integer type, and then for all the others that are not primitive types, they will have the value class type. Okay, so let's use this one, 20, and then name 3 and semicolon again, and we'll do the same here. 3 semicolon. Public. What is public? Okay, so class modifier for Java, a class can be public or final. You can't write a class as private, right? It can be public or default when you don't specify, or final when you don't want your class to be extended. So there are only 2 possibilities for class modifier, public and final. But this one here is modifying a method, right? A special method. So it has, it should have a different token value, right? Because in this, but how can the Lex analyzer figure that out, right? Because the Lex analyzer, one thing you need to understand is that the Lex analyzer doesn't have this context, right? The context will be figured out in later phases of the compiler. So for the Lex analyzer, everything is public, right? It doesn't know that, oh, is public coming before class, right? So it's a different token value, or it's coming after an identifier for a method. The Lex analyzer doesn't know that. So maybe this using class modifier in token 1 wasn't a good choice, right? Because that restricts. Maybe we should modify here and just say modifier, right? Make it more generic, right? So public is or access level modifier, even that.
So then should there even be number 6? At all?
Oh, we do have constructor modifier. Yeah, but I'm reviewing this because it's like for the Lex analyzer again, the Lex analyzer doesn't make a distinction, right? Public is public, right? So we need to condense these 2. I would get rid of this one. Funny, I didn't see this before. Perhaps we should just use access level modifier. And we can apply here as well. And then we have employee. All right, so that's an identifier. It's the name of your constructor, match the name of your class. But again, the Lex analyzer cannot do those matching yet, right? The Lex analyzer is like this. It's only seeing characters coming, and it needs to read enough characters in order to be able to classify them. But it doesn't have context, doesn't see beyond that, okay? It's kind of dumb. And then you have opening parentheses, 7, right? And then you have int. I already did that. ID is an identifier, which is 3, comma, 19, right? And then you have string, so that's a class type, and then have name, identifier, right? Okay. And so on, comma, So let's begin to question this now. String as a class type. How will the lexicon analyzer know that this is a class type? Let's think about that, right? Because instead of string, it could be any name, right? Don't you guys agree? It could be student, right? It could be book, right? So for the lexicon analyzers, actually, maybe the lexicon analyzer will just put identifier, right? Because it can't tell what is specific. That is a class. How can it? It's just a name, right? So I will review that and go back and put identifier here. Okay. It makes more sense to just these to be identifiers. It's different than int because you can't use int, right? Int it's part of the language, but the name string. String is not part of Java's language, right? String comes with the Java standard package, but it's the name of a class. And it could be anything, right? So there's no way for the lexicon analyzer to be able to tell, oh, identify string. String is not a reserved word, right? So it has to be identifier. Let's see what else. So string again. So I'm reviewing string 2 and 3. Okay. What else we have here? Sorry if I'm creating confusion, but I'm making this as a discussion with you. So department is an identifier, right? And then we have closing parentheses, date, right? Opening block. What's that? 9, right? This. Do we have a token for this? It's a keyword, right? We do have 11. 11. And then we have the dots. 12. ID is an identifier. Equal is the equal operator, 13. ID, identifier, and then semicolon. Okay? Other than that, do we have anything special here? It becomes repetition, right? The only one is the string literal. Do we have string literal? Yeah, 17. This one is a string literal. This one too. And then we have plus. So again, let me ask you this. Let's see if you guys are understanding this correct. Can the lexicon analyzer tell us whether that plus is the addition operator or the concatenation? It can't tell, right? So we'll just put a token value like just to express that was able to recognize an operator, but at this point we don't know what that operator is. Okay, so we're just gonna put 18. All right. Return keyword, right? There's a keyword return, so 15. Okay, guys. The rest is repetition. Okay, so questions about assigning token values? Are understanding this better now? Good.
As I see it, int is a keyword, not a.
Yeah, int is a reserved word, right? So it's
So I think 5 can just be rewritten as.
integer type or just integer.
Are they interchangeable? Keyword and type? Am I misunderstanding?
No, type as in, well, yes, so we know that you can just say integer or integer type.
Okay.
Right? For the lexicon analyzer, it's just recognizing an integer or an int type if you want.
Okay.
Right? Because those are part of the language. It's a reserved word.
Yeah, it's the only keyword that doesn't have keyword next to it, so it's just confused.
Yeah. So I will review that, but again, making a distinction between keyword and reserved word. So reserved word, you can't use, you can't reassign. Okay, keyword, you can, right? So if it's, then you have to look at the more details about the programming language to see if it's a reserved word or a keyword. Usually, reserved words and keywords are used interchangeable, but if you want to be specific, you have to say that you can't reassign. If you can't reassign, like define a variable named int, can you do that in Java? You can't. So int is a reserved word. Reserved in the sense that you can't reassign or redefine. Okay? Okay, so for activity 3, BNF, let's take a look. So this is just get you guys more familiar with BNF. This is a BNF for Excel or hypothetical spreadsheet software, defining an if. So you have if as reserved word here, and then you have parentheses. You have a formula, right? So you have BL. BL is a Boolean expression. And then you have two arithmetic expressions. This first one is the one that's going to be assigned or returned by the if the Boolean expression is true. This other one, if the Boolean expression is evaluated to false. What is a Boolean expression? It's two cells and you have a relational operator in between them. So it compares cells' contents. An arithmetic expression can be just the value of a cell, or it can be an expression, an arithmetic expression of two cells, or it can be another if statement. And then a cell optionally can have $8 to lock the row, right? And then you have LT, which is the letter. So actually you lock, this first one is to lock the column. And the second one is the row, it locks the row if this symbol is used. A letter is just a single letter, A, B, or E to E. And a digit can go from 0 to 9, just to simplify. So based on that, this is kind of answer, right? No. I see differently. Okay. So based on this BNF, do you think this is synthetically correct? Can you generate this expression or not? Yes or no? This question was in a midterm exam.
We agree that it's no.
Not? So what's the problem?
That last part, if it's an if, it can only do, it can do the first part and then the Boolean and the second part. and then whatever is between the semicolons is okay, but then what's the last part?
You think this one is a problem?
Yeah.
But can't an arithmetic expression be a cell? Arithmetic expression can be a cell.
Oh.
And this is a cell. You got right the no, but the problem is here, right? What is missing with this cell here? Can you have a cell just referring to the row, the letter? You still need at least one digit. We don't have that, right? So it's missing the digit. How about this one here? Looking good? Attention to detail. I'm not really good at that. Huh?
PPL be another if statement?
Can what? Yeah, so the dollar is optional. So this cell is okay, this cell is okay. All the cells are okay. Different is a valid symbol, a valid operator, so I'll say yes. Unless I'm missing something, but how about this one here? This one we have an if inside an if. Can I do that? Well, it's using another if as a Boolean expression. But if you look at the Boolean expression, a Boolean expression can be two cells compared, right? An arithmetic expression can be an if, but not a Boolean expression. So that's a no. And the last one, yes or no? This one is using an if as a cell, right? Or, yes, so, no, as an arithmetic expression. An arithmetic expression can be an if. So all of this is an if. Is this if well formed? It looks fine. I'll say yes. Should I? With confidence, yes. 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 Okay, this one is very tedious, so I'll let you guys do on your own. But basically, you start where you're weakened. So you start with an if, and then you just copy and paste. Okay, so the key is do one step at a time, okay? Now you want to expose BL. So you copy everything, repeat, and replace BL with this. But of course, you gotta pick the right operator, and you want greater than, right? So you get rid of all that. Okay? And you keep going, okay? Until you are able to generate what I asked, okay? So it's not complicated, it's just tedious, and we have a lot to do today. I'll let you guys work on that on your own. This is, now that you have the B and F, can you go back to standard notation? So from the B and F, figure out the standard notation. So variables, for example, what are the variables here? Everything that is on the left side are variables, right? So So you just pick everything that is on the left side, easy, they are variables. A, B, and C, they're not variables. Everything that is under inside apostrophes, they are terminals. So just pick whatever is under inside apostrophes, put as terminals. What is the start symbol? If, right? It's the if variable. Now you just need to do these, getting rid of BNF stuff. What is BNF stuff? This parenthesis here, that's BNF stuff. Okay? What else? This parenthesis here is also BNF. This is BNF too. So you probably need to do the recursion using variables. Probably you may need to use prime or an additional variable, right? Use prime symbols. Okay, so I'll let you guys work on that on your own, and I will share the solution later. This one is basically just doing the opposite, right? This is standard notation. How would you do this better using BNF, okay? So this is not an assignment, it's just exercise for extra practice. I will check your, I'll share the solution next time we meet on Tuesday, okay? Today I want to actually start the lexicon analyzer because the homework 3 is asking you to finish a lexicon analyzer, so we need to talk about that today. So we're going to do activity 5. And this is the grammar for this first go around. Okay, so remember that this grammar is the grammar, this unambiguous grammar for arithmetic expressions. So you have an expression, can be an addition or subtraction expression in term or a single term. A term can be a term multiplier divided by a factor or a factor. A factor is an identifier or literal. For this go around, an identifier very simple. It's just a single letter. Okay? Can't be simpler than that. A literal can be at least one digit or more. And digits go from 0 to 9. So based on that grammar, the tokens. So let's identify the tokens first. So addition operator is a token. Subtraction is a token. Multiplication, division. Identifier is a token. And literal is a token. You're not going to, as we discussed during the quiz, you're not going to identify tokens for each individual letter, because the syntax significance is for identifiers or literals. Okay, so the lexicon analyzer will help the syntax analyzer. Instead of identifying each single letter as a token, it will group letters together or digits together. In this case, it will not group letters together because the identifier is a single letter. But normally it will group letters together until it identifies a word, and it will check if a word is a reserved word, and if not, it will assign as a identifier. Literals, we only have one type of literal here, which is numbers, right? Integers. So if you were to run a lexicon analyzer for this input here, this is the expected output. So you have the lexical unit values. We're going to call that the label. The 52 will be identified as a literal. Then the symbol addition, it will be identified as addition, and so on. X, a single letter, is an identifier. Multiplication, right, and so on. 231 is a literal, so on. It will work okay for this one too. This one here, so one thing that the lexicon analyzer will do is ignore spaces in new lines, okay? So just because we have spaces here or a new line, it doesn't matter. The lexical analyzer will move from the addition to literal, and we'll get rid of all these extra space. ABC. ABC looks like a single identifier, but remember, for this grammar, each letter counts as an identifier. So the lexical analyzer will identify A as an identifier, B as an identifier, C as an identifier. So 3 identifiers. And if you identify something, a symbol that is not part, it can't be recognized, you're going to throw an exception. Okay? So let's look at a high-level view of the code that I'm sharing with you in Scala. It's going to be useful for the lexical analyzer. Okay? By the way, you don't have to use the provided code. Okay? But the only requirement is that it's written in Scala, okay? And it's the lexical analyzer. I'm going to talk about the code very soon, but you can later you're going to see that the lexical analyzer actually implements an iterator, or users of the lexical analyzer can query it for an iterator. So an iterator simplifies the interaction between the syntax analyzer and the lexical analyzer. Because the syntax analyzer is going to be another program that will ask for an iterator and will just consume one token at a time. So an iterator makes sense. So the syntax analyzer will keep going. As long as the iterator is not exhausted, it will query for next. Give me the next token. Give me the next token. So if you were to implement your own lexical analyzer, the restriction is, the requirement is that it has to be in Scala and it needs to implement an iterator. Okay. The structure is very simple. And this is, we're not going to use expression now, but it's going to be used later. Basically, you have a symbol is just a label, but it's basically a string that it can be extended. So we can associate a label. So a symbol has a label, it's a string. And a lexeme is a label with a token. So that's why we extend here. An expression on its own, an expression by its own it's a symbol with a type. Okay, so we're going to see expressions later. But at this point, we're interested in the lexeme. So lexeme is a symbol with a token. So the lexical analyzer class, it will extend an iterable of lexeme type. So what does that mean? It means that the lexical analyzer has a iterator method. So as I said, it implements an iterator, or allows the syntax analyzer to query for an iterator, and with the methods, of course, has next and next. That's the iterator interface, similar to Java. And those methods will be used by the syntax analyzer to consume the tokens. So let's look at the implementation. If you open activity 5, so best way is to create a new project. It can be a Scala idea project. Then you can just copy, you can copy everything. Okay, so under SRC, you should have lexeme, lexicon analyzer, symbol, and token. And you should also have the four source codes. Those are the ones you want to use for testing. So let's open symbol. So symbol, as I said, is just defines a string. With a label. So we're going to start seeing Scala code, object-oriented Scala code. Okay, so if you want to review the syntax or a little bit more about Scala object-oriented implementation, you can go to resources, the Scala guide, and go to classes. Okay, so there are some examples. Let's take a look. Classes in Scala, they look very much like classes in Java. There are a few exceptions, differences. What is interesting about Scala is it kind of simplifies the definition of the constructors. Okay? Especially if you have only one constructor. So, for example, this class here, this is using the traditional way. It defines just by doing class rectangle, and I don't have anything after that, like parentheses or anything after the class name. It's basically you are defining the parameter-less constructor, the one without parameter. But if you want to create other constructors, this is the way to do it. You define the methods using this. Okay, so this, when you use, you don't see that in Java, right? Using this to name the method. When you do that in Scala, it means that you're defining a constructor. In Java, you use the same name of the class. In Scala, you use this to define the constructor. Let me show you another example. So let's take a look at the student class, okay? And this is, it will look very different for you. Like you have the class, and then after the class definition here, or during the same line that you define the class, you have parentheses. This is essentially, you're defining instance variables, right? So private var ID, that's an instance variable of type integer, and the other one is var name of type string. Okay, so those are the instance variables. So you define the instance variables like in the same line where you declare your class. So that's something that will sound very different for you guys. And look at this. Let's say that you want to, well, this, where's the constructor, right? So you can just write the code within the class and outside any block structure. This is the code for the constructor of the student class, right? It's almost like it mixes together class definition and constructor definition all together.
You have instance variables, but they go before or after that?
The instance variables are already here. They are kind of the parameters. Scala infer that those parameters for the class, those are the instance variables. It assumes that those are instance variables.
And then if you want like a default, you can just or like a final, it also be within parentheses.
If you want to do a default
Or like a final
constructor,
just the instance variable inside the
you have to, any instance variable, you have to define within this parentheses. okay? To kind of force you to, like, you need to specify initial value, right? And this is the code that is checking the initial value of those values, right? And to refer to those instance values, you prefix with this, right? So it's, but the name of the instance variable is already defined, right? Okay, so those are the parameters for the constructor, and we're not using them, but they will be assigned. So request two parameters, ID and name. There's no way to create a student object without specifying the student's ID and name, so you need to specify the ID and the name. Here we're using, so we should run this code really fast. We run this one first. Let's create the student class. And I'm going to create a companion object for the student. Oops. Students. Example, just example. Okay, so it's saying that to create a student, we need to specify the ID and the name, right? So let's just create one student, specify the ID and name, and let's print that student. Okay, so this proves that although you didn't explicitly did this dot ID equals to ID, this dot name equals name. You didn't do that, but that was the effect, right? Okay, so you don't have to do that. It's assumed. Scala will do the, just because you're passing this ID and name parameters to the class, Scala automatically assumes that, okay, those parameters, we should have instance variables with the same name, and I'm going to assign the parameter value to those instance variables. So this is assumed, and it's done automatically. Why is this good? It reduces the amount of coding, right? You don't have to write this bread and butter code, right? That you always do, right? When you write in Java, when you create basic classes, you have to do assignment for each instance, you have to declare. So it simplifies coding. I think it was it's a good way to do it. Okay. Let's look at the, so hopefully this code now, it makes a little bit more sense. We have label as the parameter, and we can create a symbol just by passing a string, and this string will be saved using the label as the name for the instance variable. You can do a get label or set label to change the label. I could have used a string instead of creating this class, but I like the fact that we can modify the toString the way we want, and I wanted to show that that information is the label, right? The toString was the reason why I created this symbol class. And then we have a special type of symbol, which is the lexeme. So the lexeme extends the symbol, okay? And other than the label, you see that the label is passed to symbol label, so that's a call to super, right? And the other variable is token. So token, because token will be created here in lexeme. Let's look at the Lex analyzer now. Okay, so the Lex analyzer takes a string with the source code. So the first thing that look at the constructor. The constructor will open the source code and get all the lines of the source code into a string. The string is called the input. Okay, so the input is the only instance variable in the Lex analyzer, and it has all the code in a string. Okay, read from the input file. Then you have some methods, auxiliary methods like endOf will check if you reach the end of the file. The methods you guys will use the most are getChar and nextChar. Okay, so getChar will return the character that is right, the character at the input, right? So think of an input as a string. The first character of that string is what getChar returns. But remember, getChar does not consume the input. Okay, so those two things are separate. The nextChar, it will consume the input. So as you can see, the index is shift to 1. So, and it will update the input. So the nextChar will get rid of one character from the input. This one will check if the character that is at the input is a blank. Blank can be parentheses or tab. This one is very useful, read blanks. It will advance the input as long as there are blank characters, okay? So it's gonna be very useful. And of course, as long as not end of file. This one has letter, we'll check if there's a letter coming. Digit, if there's a digit coming. They're very useful methods. Has special, if there's a special character coming, or if there's a punctuation coming. And this is the most important one, the iterator. So it returns the iterator, and the iterator has two methods, has next and next. Has next, it will read all the blanks and will check for end of file. If the end of file is true, has next will return false. So you can't read more because there is the iterator is exhausted. Next returns the lexeme. Lexeme is a label with the token. So this is where you're going to start coding your Lex analyzer. So basically, it's reading one character and it's checking. Look, this is already doing the identifier. Remember, for this grammar, an identifier has a single letter. So basically, it's saying, oh, if the character that is coming is a letter, let's put that letter in a string. So to change from character to string, let's move the input. So let's consume that string. That's why we call nextChar. And we're going to return a lexeme object with the string as the label and then the identifier as the token. Okay? So this is already doing. How would you do to read many digits? Okay, I know that a digit is coming. right? And according to the grammar, well, if a digit is coming, I know it's going to be a literal, right? Based on that grammar. But I have to read all the digits because as long as there are digits coming, I have to put all those digits in a string and then return that string with the label literal, right? So how would you write a loop to get all the digits, put in str, and return token literal? This is your goal.
The difference between solid methods with the empty democracy and one without it.
So if a method, good question, if a method or function doesn't take parameters, you can, in Scala, you can call without the parentheses,
Okay.
but it has the same effect.
So
For example, here we can just has digits.
yeah, that's not possible. Okay, that makes so much more sense.
So we can consume that digit, right? But we need to do some loop, right? How would you structure this loop?
There's is digit is built in, right?
Has digit is a
Is digit is built in for characters, right? So can you just do while x star is digit, and then just keep looping and calling next?
yes. Right, so you can do while has digit. Just be careful that has digit call get char. What if it's end of file? You just have to be careful. It's for safety, it's better to check for end of file. So while not end of file, and has digit, get that digit, right? So you can use get char to get that digit. So if you get this error, reassignment to vol, you just need to change C to var, right? Concatenate to string, right? Reassignment to vol, just change the string to var. And move to the next one. Consume. Okay? Can also get rid of these or start with an empty string and move the loop to do everything. Like get char, concatenate next char. Can do that too, right? Get rid of this. Okay, so start with an empty string. We know that it's coming as a digit, so you're going to be running this loop as long as not end of file. And what's coming as a digit, you're going to read that digit and advance the input. Eventually, you're going to see a space, right, or something different, an operator. That's when you stop the loop. When you stop the loop, you need to return. Remember, this code is inside the next of the iterator. The iterator needs to return the lexeme, so we still need to return. And the token is literal. Okay, so the others are straightforward because there is the code for the operator. You just need to change the token that you return. The main itself reads the source file from the command line, instantiate a lexicon analyzer passing the file name, and then get an iterator in loop. As long as it has next, it will print what next returns. The first time you run is going to say missing source file. You just need to pass one of the codes. So let's say source 1, just to illustrate. So look, we got 52, so it worked, the literal, right? We were able to addition, of course, identifier. The next one, it was a multiplication, right? So we need to put the multiplication code. So right now, the lexicon analyzer doesn't know how to identify multiplication. You just need to copy this code here to here and change this one to multiplication. So now we should be able to move multiplication, another literal, but then it's division, right? So we need to add division here. Just go ahead and do the subtraction to finish today. Okay? So, study this code, because this code is going to be like the shared code that you guys are going to use to do the homework. Okay, homework 3 was assigned. I kind of rushed today. I'm sorry, but I wanted to share this code so I know that you guys are busy. Sometimes you only have time during the weekends to do homework, stuff like that. So I wanted to give you enough information So you can at least start your homework this week, okay? The next activity, we're gonna do the same grammar for this Lex Analyzer. The only difference is the identifier it's not gonna be a single letter. It can be a group of letters. You guys can start doing on your own. Look at the next activity and try to see if you can figure out how to do it. Study the code. It's kind of the assignment. Study the code so you can do the homework, okay? And we can continue this one too. All right, guys, have a great weekend. I'll be sharing this code on GitHub, okay?